The Rosetta mission is exploring two key scientific questions. Did water on Earth come from comets? And did comets help kick-start life on Earth? To do this, there are 11 instruments on the orbiter and 10 on the Philae lander. And since Rosetta came out of hibernation in January, we now know Comet 67P's mass, shape and rotation. Rosetta's cameras have shown gas and dust streaming away from the comet, locating areas of activity and imaging them for the first time. The orbiter has also detected water and gases in the comet's atmosphere, or coma. And the COSIMA instrument is capturing dust grains on a target just 1 centimetre square. The grain detection system and impact sensors measure the mass and velocity of grains, allowing scientists to identify which part of the comet the grains come from.
This is the comet. It's roughly a 1 in 1,000 model, so the real thing is 1,000 times bigger. The landing site is roughly here, which we're aiming for to deliver the lander. It's the flattest part we could find.
This miniature version of Comet 67P, Churyumov Gerasimenko, is at ESA's ESTEC facility, where Rosetta was tested before launch.
What we are studying at the comet with the instruments are basically what are the ingredients, which materials are present, and coming back to one of the objectives of the mission, how complex are the materials present at the comet.
The chosen landing site is close to areas of activity, so landing will be technically and operationally challenging. It could be a hard or soft landing, as the composition of the surface material is so far unknown. The comet's mass, of around 10 billion tonnes, and low density suggest it is porous. The lander's instruments will use light, electrical conductivity, magnetism, heat and acoustics to examine the comet's properties on, above and below the surface. Surprisingly, the ALICE, Virtus and Miro instruments have shown that the comet's surface is relatively free from ice, even though it's far away enough from the Sun to remain intact. Instead, it's more of a dark, thermally insulating, dusty crust. But then this mission has been full of surprises, and there will undoubtedly be more to come.